Hey everyone, Adam the Tutor here, coming at you with another Laplace transform video. Now this one, we're basically just saying, hey, okay, we've already done a lot of powers of t, let's just make it general here. So in this one, our f of t is t to the n power, right, where n is some integer. It's like, 2, 3, 4, 5, whatever, what have you, right? So, without further ado, let's just go ahead and go for it. Right? Okay, so this is the Laplace transform of t to the n, and that's going to be equal to this guy, right? I'm going to have t to the n e to the minus st, right, dt. And as you might have guessed, well, this is basically going to be an integration by parts problem. And for all intents and purposes, we have to do integration by parts n minus 1 times. But luckily for us, we're actually not going to have to do that. In principle, that is what we're doing. But I think after I do it about 2 times, I think you'll kind of see the pattern. So let's just go ahead and get started. Okay, so the very first one. Okay, so let's just do it under here. So our u is going to be t to the n. Our dv is going to be e to the minus st dt. So our v is negative 1 over s e to the minus st. And our du is going to be n t to the n minus 1 dt. Right? So we have our u and our v, e to the minus st, and then that's t is equal to 0, t goes to infinity, minus the integral from 0 to infinity, and then it'll be a v and then du, which will be n t to the n minus 1 dt, right? So, again, like we did in the last video, well, we have our first term, which will be t going to infinity. Well, this guy's going to go to 0 there, and we have t is equal to 0. Well, this guy is going to be 0 here. So this whole first term is just 0. So then we're left with this guy, right? So now what we're going to have is we're going to have another integration by parts, right? And, again, it'll be the same thing. Now let me come over here. So this time, our u is t to the n minus 1, right? And so our du is going to be n minus 1 t to the n minus 2, right? And then dt. Our dv is, well, just basically the same, right? dt. So our v is going to be negative 1 over s e to the minus st, right? So now, what we're going to have here is we're going to have okay, so let's just go ahead and factor everything out right away. We're going to have an n that comes out of here, we're going to have a minus minus, and there's going to be a plus 1s. So this is going to be n over s times u t to the n minus 1 times v minus 1 over s e to the minus st. And that's t equals 0, t goes to infinity, minus the integral from 0 to infinity. Okay, so I know I did this first integration by parts kind of out of order, but let me go ahead and do it in order this time. So we're going to have n minus 1, and then t to the n minus 2, and then we're going to have a 1 over s minus 1 over s e to the minus st, and then we're going to have dt, right? Well, again, it's basically the same story, right? This guy, if I evaluate this in the limit that t goes to infinity, this guy is 0. If I evaluate, so that makes everything 0. If I evaluate this at t equals 0, this guy is 0, thus making this guy equal to 0. So again, I'm finding that this whole thing is 0. And so then I'm left with an n over s, so then I'm left with this. N times n minus 1 over s squared times the integral from 0 to infinity t to the n minus 2 e to the minus t dt. So as you can imagine, here's what's going on, right? This first term in the integration by parts, no matter how many times I do it, is going to turn out to be 0, right? Because I'm always going to have a power law right here, which will be 0 when I evaluate this bound. And I'm always going to have an exponential right here when I evaluate this bound, and that will be 0, right? So this whole first term right here, this whole first term is always 0. Always 0. So then all I have to worry about is the second term right here. And basically what's going on is every time I do integration by parts, I get a minus 1 over s, which cancels this minus sign, so I get a positive, and I just keep decrementing this exponent by 1. So basically if I do integration by parts again, I'll get an n minus 1, n minus 2 over s cubed times this integral. N minus 3 dt, right? So I think you can kind of see where this is going. So if I keep doing this, eventually it's going to come to a point where it's n times n minus 1 times n minus 2 times n minus 3, and we keep going, and eventually we get to 3 times 2 times 1, right? And we'll have an s to the n minus 1, and then we'll have times, so basically what we've done here is we've done integration by parts n minus 1 times, right? Because here we did it twice, here we did it 3 times, here we did it once, here we did it twice, right? So here we did it 3 times. So here we're doing it n minus 1 times, right? Because when we need to take the derivative of this n times to get it equal to 1, which would require n minus 1 integration by parts. And so basically, eventually, we'll end up with this. Yeah, so this right here is equal to, well, this is just n factorial, and then this is just s to the n minus 1, right? So, let's kind of check this, right? So we have that the Laplace transform of 1 is equal to 1 over s, right? So this is t to the 0, right? So in this case, n is equal to 1. Well, then we get, actually this should be plus 1, sorry, because there's going to be another factor of 1 over s that comes here. So let me actually fix that. Times 1 over s, which remember, this 1 over s is going to come from when this guy dt is equal to 1 over s, right? And that's where this extra 1 over s comes from. So, oh, and this should actually be s to the n. Got my counting wrong there. Okay, so this is s to the n, right? Because this was 2 integration by parts, this was 3 integration by parts. So if I integrate if I do integration by parts n times to get this guy at the end of here, so then that should be n plus 1. Okay, there we go. Sorry about that mistake. So let me go ahead and just actually here. So let's just check this with what we already know. Laplace transform of t to the 0, right? T to the 0. So if I plug in 0 into here, I get, well, 0 factorial over s to the 0 plus 1, which would just be 1 over s, right? And if we do the Laplace transform of t, we get, okay, well, we get 1 factorial, and then over s times 1 plus 1, which is just 1 over s squared, right? So, hey, we got a good match here. And, if we really wanted to do it, I would have done the Laplace transform of t squared as well. But according to this formula, it should just be 2 factorial over s cubed, or 2 times s cubed, right? So there we have it. We have that the Laplace transform of t to the n is equal to n factorial over s to the n plus 1, right? I know I kind of messed up there for a little bit, got kind of turned around, but this is in fact the correct formula. Okay, so that's basically going to do it. Now we can basically transform any polynomial, right? Because we can do this for any integer n, right? So that's basically going to do it for this video. If you have any questions or comments or concerns, just leave them in the video below, or not the video below, the comment section below. And that's going to do it for this one. So I'll see you in the next video. And thanks for watching.